So in a prior video, we worked on a way to assign a ship that's coming out of a port, assign it onto a path to get it out of the port and into open ocean so it doesn't get hung up on the coastline. It works really well. I like it, except for if we click on each one of these ships, you'll notice that the path is exactly the same. I decided I didn't really like that, and I'd like to vary the path for each ship that's coming out. So an easy way to do that would have been to have 3 or 4 paths, and then you could just sort of randomly assign one of those paths to each ship as it comes through. And some of them might be on the same path, and there'd be different ones. It would have been sort of random. I decided I wanted to figure out how I could make each one of these waypoints a little bit more random for each ship, and it worked out pretty good. So we're going to see if we can recreate that here. So I'm going to go ahead and return all of these guys back to their base. We'll speed time up so they get back to the base. Actually, maybe we could slow that down a little bit so we have time to think. And we're going to get this one guy here, and we'll put him out in the middle where we can work on him, and we're just going to give him a path around just to see what it's like. We're going to grab the unit ID, and we're going to open up the Lua console. So from here, we're going to type in the basic local U. Set it at get units, paste it in between the parenthesis, and that doesn't do anything. We need to print U. And we already know we're not going to get the course, so we're going to go directly for the course and print that out and see what we get. And there we are. We have some waypoints here. So what can we do with that? Each waypoint has a lat and a longitude, and then it says type of manually plotted course waypoint. That part probably doesn't matter to us. We just want the lat and long for each one of these waypoints. So when we print the course, we could also print, I think we can just do 1, and it'll give you, this is the first waypoint, latitude and longitude. You could also do dot latitude and get the exact number of that latitude. Now what if we want to take this, and what we want to do is change that? Can we set u.course 1.latitude equal to, what did the number come out to? 40.74. Let's just see if we can set it to 40. So we're going to set it to 40 in the second line, and then the third line we're going to print it and see what it is. And it did not take it. So you can't manually edit the waypoints. So how else can we do this? You can definitely edit things in this manner if you had your own table. So let's get rid of this part. U.course is the table that has all the waypoints. We'll make up our own variable. We're going to call it new course equal to u.course. And now we're going to print new course just to make sure it's going to be the same. And there it is, new course, which doesn't have anything to do with the unit anymore. It's its own table. Now if we do, what are we going to do? We're going to do the same thing. Let's see if we can set one of those. So this is going to be new capital C course 1.latitude, and we're going to set it to 40. And then we are going to print new course 1.latitude. And it's going to be different because we are going to be on to a new, what's it going to be now? It is going to be the second waypoint because the ship just turned around the corner. So now it's on that waypoint. The latitude is still 40. That we probably should be safe. We should do something like 0.7 to make sure it's not very far away. Actually, it didn't matter because we're not manipulating the actual course of the ship. We are manipulating the new course. So now if we stop the game, and back here, if we do So you can't manipulate a specific waypoint, but you can set the entire course, and we've already done that before in the prior one where we assigned every ship that course. So if you know a course that has the correct waypoints, you can apply that. So if we do this, then we're going to want another print to see what u.course is. The first waypoint should have this latitude. Waypoint number 1, latitude 40.7. So, and you can see it bounced from up there down to there, I think, right? What was it before? It was 40.78. Let's add an 8 to it and see how far it changes. Yep, that was sort of a big change. So that's interesting to know that 0.7 to 0.78 is a fairly large distance. Not in reality, that looked like it was maybe 5 or 6 miles. If we're going to have them come out through here and back up there through the straits, we don't really have that much room. So we're going to want to plot a course and then make slight changes to that course, but it can't be 0.8. We need something more like 0.00 something, and then maybe 0.01. So let's change this to 1 and see what it does. And then compare it to 7. That was because that was still 7 hundredths change. So just 1, maybe 2 is about what we want. Is 0.01 at the most, I think, is the biggest change we want. So now we have to figure out, so you can sort of see we can loop through each one of these waypoints. We did that before in the video about tables. So let's see, how much of this do we need? We've already set the new course. We're going to do a for I equals 1 comma pound sign new course. The pound sign in front of the name of a table, it gives you the number of items in that table if it's an array-like table. It has to be an array-like table where this is 1, 2, 3, 4. In the prior video we did about Lua tables, they don't have to be like this. It could be a sparse table where it skips number 3 and goes straight to number 4. In that case, pound would equal 2, I believe. It could also be a dictionary style where this isn't 1. It could be the name of something, and then this could be like a key value pair or something. But any course is going to be the proper kind of table where we can do pound and then the table name to get the number. So it's going to be 1 through 4. We have 4 waypoints. And then we're going to say do, and then down here we're going to have the end. And I like to mark where the ends are of anything that I do, so I know where they are. And once you do an if statement inside of this, it gets complicated to know which end goes with what. For I equals 1, new course do. And we could do what we just did a minute ago, which was new course. And this is going to be I instead of 1, and then we'll get 1, 2, 3, and 4 dot latitude. And it helps to spell these things right. And we're going to say it's equal to itself. And then it's going to be plus 0.01, we'll say. And now we could do the same thing for longitude. And why don't we do that? Probably should have made sure the first one worked before we got this far. It's always easier to correct mistakes on less stuff. So we're going to say that the waypoint number 1 latitude is equal to the current latitude plus 0.1. Longitude of waypoint 1 is equal to longitude of what it is now plus 0.1. And then it's going to loop through and do that for the waypoint 2, waypoint 3, waypoint 4. And this isn't what we're going to want to end up doing. We're going to do this randomly, but just as a proof of concept, we're going to do this and see what happens. So watch these points over here. With any luck, they will change. Or they won't, because we didn't assign new course back to U course. So we basically need to reverse this. We just did it to... so this is going to be the equivalent of doing this twice, because we're going to run it through again. I think that'll be okay. So we didn't assign the actual unit's course back to what we did. We were only manipulating our placeholder course, which wasn't affecting the actual unit. And now you can see it's changing. It's always going up. That's not really what we want. What we want to do is add a plus or minus 0.01 something. So for that, we're going to write some sort of function that's going to have a random number in it. Ship path offset. Try to give, when you make a function, if you're doing your own scenario and nobody else is going to be working on it, you can be sort of loose with the function names. But if there's any chance somebody else might work on it, or if you're using a starter scenario that's got some stuff in it already, you should always make sure to use very specific function names. If I just called this offset, there's a chance that something else I'd be using has a function named offset, and that would be bad. And then this is going to needs this part of it. And then we need to end. And then we need to decide what we're going to do in here to give us a random number. And in here we're going to need some sort of local variable, and we're going to call that offset. It's equal to math.random something. And if we just do math.random, it's going to be a random decimal between 0 and 1, and that gets messy because it's a lot of digits. We could do I want some decimals. We're going to end up dividing by 1,000 or something. So I want kind of a long number, maybe 3 digits. So if you want 3 digits in your random number, I think there's a lot of different ways to do this, and maybe I'm not thinking of the best way to do this, but I think I want to start in the hundreds. So if we do 100,999, that's going to give us a random whole number between 100 and 999. I want the number to be positive or negative. So we could subtract 500. And then we probably need to divide it by something because it's going to be too big. Offset minus 500. So if the random number comes up as 600, we'll end up with minus 100. That'll be minus 10. That'll be minus 1. That'll be minus 0.1. That'll be minus 0.01. That might work. Somewhere in here we need to do a print. If you don't do these print statements everywhere, it gets really hard to know what's going on. So we'll print the offset. We're going to print this. And then we're going to return the offset when we're done with it. So the function is going to call this and it's going to get something back. It's not actually going to give the function anything. And then over here where we have plus 0, 1, we're going to call the name of this function, but we're not going to pass it in anything. It's just here. What happened there? It's just here to give us a random offset value that hopefully is around 0.1. And we made the function above the code that calls it because the function needs to be loaded before you call the function, so it always has to be first. And let's see. We're just doing this on this one ship, so we don't actually have a path. Eventually we're going to need a path variable. But this might work. Let's see what happens. Error. Line 15, unexpected symbol near period. And there's a period right there. Okay, interesting. I saw something change. Random number is 720. Offset equals 0.022, 0.013, 0.0361. That looks pretty good. I'd say, so one thing that's hard to tell is that since the path is updating every time, which isn't what's going to happen, I just want the fixed waypoints to be slightly different for each ship. So what we need is the path that the ships have, and that is in here. That is this course that we were manually putting in there. And this is where all this code is going to end up going, is back in there, but we don't need to put it back in there just yet. We need we can use the same new course variable here. We'll use it up there, and then instead of down here, actually that's right above it, we can get rid of that. We're going to have to put the ship back over by the base, which is no problem. We're going to move this back out here. And now when we run this multiple times, it should be, it shouldn't move around so much because it's always going to come back to the base course that's set. So let's see what happens when we run this. That looks good. Okay, so you can tell that we go to overland. We're changing, the number is a little too high. And you can see that right there, 0.03. And there's even a 0.04. So if you go back and look at what our function is, and that's here. Let's give it a space there so we can read it again. We are calling a random number between 100 and 999, and then we're subtracting 500. So the most it could be, if the number was 100 minus 500 would be minus 0.4. Well, it would be minus 400, then divided by 10,000. And if it was 999, it'd be minus 500. That'd be minus 4. That'd be 499. Those are too big. So this number range here is too large. So we could shrink it and say that's 300. So we added 200 onto that. Let's change this to 799. And that seems like we should just make this 700. So there's an equal chance if 500 is the middle. Then you got 300, that's 200 on either side. Minus 500, if it is 500, we're going to get 0 offsets. That's probably okay. And now let's see what happens when it runs. Again, these existing waypoints don't matter. Doesn't matter where we move these to begin with. When we run the Lua console code, it's working off of this course up here that's hard-coded. So now let's see how we do. It's pretty good. The main thing we want to see is that it stays within, it stays over ocean. So there's a limited amount of space that we have when it goes right through this point. I think all of those paths would work. But that's still, so all those paths I think would work, but it's kind of a bigger change than what I was hoping for. So, but we're close. We could divide it in two if we just change this from 10,000 to 20,000. Whatever we get up here, 0.149, it'll just divide that in half. And now let's see what we get. That's what I was looking for. It's a change, but it's not a very big change. So now with this code, we can plop this back into the action. We don't need that anymore. That's going to be the top line in the action with unit X. We've got the new course. We've got the function to offset. We've got all that. And then there is the bit about changing the doctrine that we need. And we're going to make sure we don't overwrite that. The doctrine was to allow it to not ignore the plotted course until it gets outside. Otherwise, if it ignores the plotted course, then we've screwed up. So we have an if condition here. If it's returning to base, don't do anything. We need to leave that. And then this is the else. We no longer need that. Probably doesn't matter if we put all of it in here. But that seems weird. I can't say I'm a big fan of that. I'm going to put this. Leave a space there. I'm going to put this stuff at the top. So we got the new course up at the top. Longitude. That all looks pretty good. So there's one thing that we are leaving out here, and that is the random seed. That as this is, that's not going to be as random as we would like because we haven't seeded the randomness. And to do that, you need to do random. I guess it's math.random seed. And then you put something in here that's usually os.time. There's a couple other ones you can use. I've tried os.clock, which is a smaller, it's supposed to be milliseconds. I still don't 100% understand the random seed part. Some of them, when I've been playing around, the course is not going to be any different. If two ships come out of the port at the exact same time, they're still going to end up being on the same course, I believe, and it has something to do with the random seed. All right, let's see if this is going to work. Okay, that's all we should have needed to do was to change that one thing. This guy, we can tell him to return to base, and we'll move time up and see what happens. Okay, so we got our first ships coming out here. And they've got different courses. Except for that guy doesn't have a course period and he missed it. So every once in a while I do see somebody sneaks out. I think it has to do with there was a bunch of ships left at the same time. And there's no. Okay. I think that works pretty good. Yeah, it looks like those first two have the same exact course. And that guy too. So 3 of them got the same exact course somehow. Haven't quite been able to figure out. Actually, that maybe looks like a 4th one. No. I think it has something to do with the massive ships all leaving at the same exact time. Same thing with the one that didn't get the course assigned at all. That one was going to bump around, so it just returned into base. And here comes another one. And you can tell that they all share the same waypoints, but they're all slightly offset from them.